Hey guys, welcome back. For today's video, we are going to talk about our chapter 8, which speaks about what is my line, and more specifically, we're going to talk about the least square regression line. So as we know, the least square regression line is basically the line that is formed through your scatter plot. Here I have a definition. That is a unique line such that the sum of the vertical distances between the data points and the line is 0. And you know that this is another name for your residual. So if you look at the diagram I have here, is that these dots in blue represents your data. And so for this point, the observed value or the actual value is a 0.07, but the distance between the line where the model predicted came out to be 0.032. So in this case, you realize that the model underpredicted this point because it falls below the line. For example, the one at the bottom here, the actual distance was a 0.02, but the model predicted to be 0.2028. And again, the model overpredicted this point. So basically, your least square regression line, which you'll hear being called LS, least square regression line, LSRL, you'll realize that it is a prediction of your model. And once you can determine the values of A and B, which is your intercept and your slope, you should be able to do further calculation, hence interpret your data. Let's move on. Okay, so the formula for your least square regression line is for you to find, so y hat is equal to A plus bx. And I said to you guys before, once you see y equal mx plus b, y equal a plus bx, once you can identify that the coefficient of the x variable, which is the number in front of x, that's always your slope, and the number that stands on its own represents your y-intercept. So in this case, b represents our slope, and a represents our y-intercept. All right? And you guys know how to interpret that already. If not, I will explain it to you in a future lesson. So we want to know what is the value of A, what is the value of B. We do this because we are not given, or sometimes we're not given the graph, but we're given critical points of the graph in order for us to find the value of A and B. In previous classes, we used Desmos graphing to graph the equation to tell us the value of A, the value of B, or M and the B, and we put it in the form y equal mx plus b, put in the value of A, put in the value of B. But for this one, we are going to use actual formulas to find the value of B and the value of A. So to find your slopes, we use B is equal to R sy over Sx. If you're doing AP statistics, you will be given the values of x, the values of y. Then you're going to calculate your correlation coefficient, which is your R value. Then you will calculate the standard deviation of your y values. You also calculate the standard deviation of your x values. But for CP classes, we don't go that far. All we focus on is the critical points, R, correlation coefficient, Sy, the standard deviation of your y values, Sx, the standard deviation of your x values. And here we have the word response, and you know your response variables represent your y values, your explanatory variables represent your x values. So we're going to focus on this formula if we want to find the slope of our least square regression line. Alright, so the y-intercept is denoted by the letter A, which is saying A is equal to y bar minus b of x bar. B, we know already, represents the slope from the initial stage. Y bar represents the mean of y, and x bar represents the mean of x. These two formulas help us to find the y-intercept and help us to find the slope. If you want to, there are going to be instances where you're going to have to find different variables from your formula. You can always solve for that variable and make it be the subject, and then you can move on. I'll teach you how to do that in a minute. Alright, so here we have an equation, a scenario where it says calories and we have sugars working with. So this one says the mean of y is equal to 107 calories. Standard deviation of y is equal to 19.5 calories. So once I see the y variable here, I know that calorie is representing my y variable. So if you think about your graph, calorie would be like right here, and down here would be sugar. Because again, mean of x represented on the x-axis is 7 grams. Standard deviation of x is equal to 4.4 grams. Correlation coefficient is 0.564. You're asked to find the slope and the intercept and write your equation using meaningful variables. Okay, so I already have an idea in my head of what my graph will look like if I'm asked to graph this. So since I'm not asked to graph that, I'm asked to find the slope and the y-intercept. I now need my formula. So the formulas we mentioned just earlier, we need these two formulas. So let's go.
Point of interruption. If you would like to join in at prayer at the flagpole, please come now. Prayer at the flagpole, please come now.
So the first equation, b is equal to rsy over sx. Here we want to find the slope, and that's our b. We also want to find the y-intercept. It says a is equal to y bar minus b of x bar. We're going to find that as well. So mean of y, as you know, that's going to be your y bar. Standard deviation of y, if you look at your formula here, only one of them could be, and it's going to be your sy. Mean of x, that's going to be your x bar. Standard deviation of x, that's going to be your sx. Again, from your formula. Correlation coefficient, that's already your r value. So once we can label the critical points given to us, we can now substitute the values into the formula. So let's go. So b is equal to r, and that's my correlation coefficient, and that's 0.564. Sy is my standard deviation of y, that's 19.5 times the 19.5. Here I put the parentheses because these two are combined. Meaning they have a relationship. In this case, they are multiplying by each other. So if you want to put a multiplication sign there, you can do that. So all of that is being divided by Sx, which is the standard deviation of x, which is going to be 4.4. Now, we're going to be using our calculators to do the calculation because I don't use my brain. So let's go. So it's going to be 0.564 times 19.5. And remember, once you have fractions working with you, work your numerator first, then you press enter, then you divide by the denominator. You do not add them in the same line. So here I have 10.998. I'm going to divide that by 4.4. And that should give me 2.4995, so 2.50. So I'm sure what I have, 2.4995. You can leave it as that if you want to. We normally go to 3 decimal place, but it will still be 2.5 because if you add 1 to this, it becomes 10. You have to keep adding 1. So we're going to leave our slope as that for now. So our b value is 2.4995. 3 decimal place or 2 decimal place should be okay. It won't change your value much, but do not round off too quickly. Now we have our slope. Now it's time for us to find our y-intercept, which is our a value. So all we have to do is to substitute the values we have into the formula. So a, let's draw a line down. So a is equal to y bar, which is going to be the mean of y, 107, minus b. We just found b right here. So this is the b that we need to put for our answer right here. I'm going to use the parentheses to put it there because sometimes your slope may be negative and you have to know what to do when your slope is negative. Alright? Alright, so now we have x bar, and x bar is 7. So I'm going to multiply that by 7. If you have a calculator, you can plug everything at the same time, or you can work it by parts by multiplying these two sections first. It's up to you how you want to do it. I'm going to put everything in the calculator at once, so it's easier for me to work instead of having to type so many things. So let's go. Here I have 89.5035 for my answer. So A is equal to 89.5035. You could run it out if you want to. I'm just leaving my answer as that. Okay, so now I have my y-intercept and I have my slope. I now need to write my equation of the line in the form. I'm going to go up here. Y hat is equal to A plus BX. I need to know what is A, I need to know what is B, and I'm going to put it into the formula. So let's see if I can change my color. So Y hat is equal to A, 89.5035, plus, in this case my slope is positive, so plus 2.4995x. This is the equation of my model, my least square regression line. Same as saying the equation of your model. Okay, so this is it. Now they want me to use meaningful variables, meaning in real life, what is X, what is Y? All you have to do is to go back in the initial stage, they'll tell you what they are. So they're saying that Y represents calories and X represents sugar. So all you have to do is to put the values of X and Y right there. So let's go. So since as Y is calories, I'm going to say calories hat. That's spell right. Always. Calories hat is equal to, I'm going to rewrite whatever I had before. 89.5085 plus 2.4995. Here, instead of having X, I'm going to put sugar. So I don't need parentheses, I'm going to put sugar beside it. S-U-G-A-R. So there we go for our equation using meaningful variables. All I did was to tell you what is X and what is Y. X is sugar, Y is calorie, and there you go for your equation of the line and using meaningful variable. Again, I found my slope and I found my y-intercept and I just plug them into the formula and find whatever I need. Alright, so these two formulas are very important. You need to remember them. On tests and quizzes, they will be given. It's up to you to know how to use them. Alright, thank you very much for watching. I hope this lesson was useful for you. You should be able to answer the question that will follow. I'm going to go in another video to explain to you how to do it if you're not given the different labelings. Instead, you're given a table to work from. So very soon, you will see that coming up. I'll see you on the next